Hello, I'm Ishwar. This is my project on fault-tolerant distributed embedded control system with a real-time digital twin. The system uses 4 independent microcontrollers communicating over a CAN bus at 250 kbps. The system has 4 nodes. This is node 1, Arduino UNO. Node 1 is the sensor hub with MPU6050 for vibration and ACS712 for current and two DS18B20 temperature sensors. This is node 2, Arduino Nano. Node 2 controls a 300 RPM DC motor through motor driver and one LED bulb through a relay. This is node 3, ESP32. Node 3 is the supervisor with the status LED and a buzzer and a push button. This is node 4, ESP32. Node 4 is the gateway with a 2.8 inches TFT display showing a real-time data. You can see, and all nodes communicate over a CAN buses. Here for CAN bus I uses two MCP2515 for Arduino UNO and Arduino Nano and two TJA1050 CAN bus for both ESP32s. Here node 1 reads the sensors and sends the data through a CAN every 2 seconds. And the accelerometer or a gyro sensor measures the vibration. You can see the value changes when I tilt or bend. The current sensor measures the motor current. You can see on display. The two temperature sensor provides a primary and backup temperature monitoring. When I touch the sensor, you can see the temperature changes on TFT display. See, temperature 2 is changes, increasing. Next, node 2. Node 2 receives a command from the node 3 and controls a motor and relay. The motor speed can be changed from 0 to 255 using PWM, and the direction can be forward or reverse. The relay controls a bulb simulating a thermal load. Here you can see the motor spinning and bulb turning on and off. You can see on display node 2 motor speed 150 rpm and the direction is forward and relay is on. The bulb turn off. The relay is also off. Here two relays. I only used one relay for a bulb. Motor spinning at 150 rpm. See, now motor speed decreases to 100 rpm. Now it changes the direction. Now it's spinning to reverse direction. You can see on display it's showing, and the motor stops 0 rpm. Next, node 3. Node 3 is the supervisor. It monitors all the nodes. Here the green LED indicates node 1 is active, white LED indicates node 2 is active, and blue LED indicates a fault. Currently it is off, so system is normal. You can see on the display also, system is normal. The last, node 4. Node 4 display all the system data on this TFT display. You can see node 1 temperature, current and acceleration, and node 2 motor speed, direction and relay status. The bottom shows the system status. Currently it's a system normal because all nodes are working correctly. Now watch the fault tolerance feature. I will disconnect a node 1, the sensor hub. The system has a 4-second timeout. If no data is received from a node for a 4 seconds, it declares a fault. I am disconnecting node 1. Wait for 4 seconds. As you can see, green LED turned off, blue LED is blinking, buzzer is sounding, and TFT shows the system fault. You can see node 1 is offline, system fault. System detects the failure automatically. To recover, press reset button on node 3. You can see push button. The system recovers immediately, buzzer sound off, blue LED turns off, node 1 can be reconnected and system will be resumed to normal operation. If I reconnect the node 1, the system back to normal operation. For node 2 also same. If I disconnect a node 2, if no data is received from a node for a 4 seconds, it declares a fault. I am disconnecting node 2. Wait for 4 seconds. As we can see, white LED turns off, blue LED is blinking, buzzer is sounding, TFT showing a system fault. You can see node 2 is offline, system fault. To recover, press reset button on node 3. The blue LED turns off, buzzer sounds off. If I reconnect the node 2, system back to normal operation. For node 3 also same. If I disconnect the node 3, the blue LED blinks, buzzer sounds, and no operation will be done. In TFT it shows system fault and system will be freeze. To recovery, press reset button, and if I reconnect the node 3, system back to normal. You can see. For node 4, if I disconnect the node 4, it does not affect on any system operation. See, I am disconnecting node 4. The system operates normally. Only effect on TFT display shows the node 1 offline and node 2 offline. If I reconnect the node 4, the TFT also works normally. This project successfully demonstrates a fault-tolerant distributed control system using a CAN bus. It has applications in industrial automation, automotive system, building management and critical monitoring system. Thank you.